Number 44, find the radius of convergence for the series 2n factorial x to the n divided by n factorial squared. First thing we do is find where it's centered at, and we can see right away that it's centered at 0. Next, to find the radius of convergence, we use some test that we can compare to 1. And the test that we use most in most of these problems is the ratio test, which simply says the limit as n approaches infinity of an plus 1 divided by an, the absolute value, and if it's less than 1, it converges. So I already started a little bit here, but I'm going to go through it anyway. The limit of n as approaches infinity of 2n plus 1, we just add 1 to an, all the an's, and that becomes 2n plus 1, x to the n plus 1 over n plus 1 factorial squared, divided by an, which is just a reciprocal of this n factorial squared, 2n factorial xn. I already started crossing some stuff out here, but I'll go over it again. So I'm just going to expand here of 2n plus 1 times x to the n plus 1, and n plus 1 factorial squared is the same thing as saying n plus 1 factorial times n plus 1 factorial, and the same thing with n factorial times n factorial. And what's going to make this nice is everything's going to cancel, and I already started doing that in this step, but I'll go back over it again. 2n factorial xn. So close that out here. So what we see here is this cancels here. The plus 1 just means that it's x. I'm sorry, I forgot a factorial up here. But 2n factorial is going to cancel out here with this factorial, because if you expand it, it would be, for factorials, 2n minus 1, and then another 2n minus 1, and it keeps going and keeps going. So the next minus 1 would just be 2n factorial, which cancels out here. The same thing with these factorials. If we expand on this, it would be n plus 1, and then minus 1 would just be n factorial, and the same thing here. So these cancel out with this factorial down here, and that leaves us with just the limit as n approaches infinity, the absolute value of 2n plus 1 times x over n plus 1 times n plus 1. Now that we have that, we can take out x because it's not dependent on anything, and we know that all of these are going to be positive, so we take out the absolute value of x and then evaluate the limit infinity as 2n plus 1. I'm sorry, we can get rid of that. 2n plus 1 divided by, if we FOIL this out, 2n squared plus 2n plus 1. And from there, we can evaluate it using direct substitution, which just substitutes infinity in for all of the n's, and we get the limit as n approaches infinity, which is actually going to be infinity over infinity, which is an indeterminate form. So we use L'Hopital's rule, which equals the absolute value of x, which it still should be over here as well. The absolute value of x as limit approaches infinity, and L'Hopital's rule simply says that we take the derivative of the top and the bottom separately, which will end up getting 2 over 2n plus 2, and then we use direct substitution again, and we get the absolute value of x, plugging it in, times 2 over infinity, and as infinity approaches 2, it goes to 0. So we have absolute value of x times 0, which is less than 1. So 0 is less than 1. And for this case, that's true for all values of x. So the radius is infinity. have it.